Hello, welcome back. In this video, we're going to go through an example about finding the domain and range of a function. Well, just to remind you, the domain of the function can be described explicitly or it may be described implicitly depending on the equation provided to us. Okay, and the implied domain is the set of all real numbers for which the equation is defined, and the range is the set of all the images coming from the domain of the function. And let's try to find the domains and ranges in each case. Okay, let's look at part A. Part A is the difference of two square root functions. One is square root of x and the other one is like square root of 3 minus x. Let's try to construct a domain by just looking at the statement of the function. So the only thing that we should remember about square root functions is that you're not allowed to input a negative number under square root, okay? So that's the only thing I remember about the square root function. So this number, whatever you put underneath square root, has to be greater than or equal to 0. So I'm just going to follow this rule to look for the domain of the function. All right, so I have root x here. For this type of expression, all I want is that x's are non-negative. And for this one, as you see, 3 minus x is non-negative. Well, from algebra, we know how to read this. So essentially, this is minus, so we should probably add plus x to both sides. So it becomes 3 greater than or equal to x. So I have two things. I have to combine these two things to deduce that the domain of the function is the set of all values of x for which, in one case, well, it has to be non-negative, and also it has to be less than or equal to 3. So that means that the domain of f is the set of all numbers non-negative starting from 0 all the way to 3. Okay, this is the bracket notation. When we have this type of domain, what are the images of x's coming from the domain? Well, when x equals 0, this is 0, and then this is positive 3, 0 minus root 3. That's what you get in the image. Okay, so you get negative 3. When x equals 3, so this becomes 0 and this becomes root 3. So we get root 3 in the output. Okay, so in other words, all the values of the numbers coming from 0 and 3 would be stuck in between negative root 3 and positive root 3. So this takes care of part A. Let's check out part B. Part B is the g function is defined as 1 over the absolute value of x squared minus 4. So this is a specific function called rational function. It's top divided by the bottom, or numerator divided by the denominator, and we want to be careful about the denominator. We don't want the denominator to be 0. Okay, so first we should find x's for which x squared minus 4 is equal to 0. Okay, the absolute value of x squared minus 4 equals 0. But if the absolute value of inside is 0, then it should imply that x squared minus 4 equals 0, right? And this implies x squared equals 4, and here x could be plus or minus 2, right? Both minus 2 and minus 2 have the square 4. So we have two options coming out of solving x squared equals 4. One is negative 2, the other one is plus 2. All right? And for all other x's, this function is defined without a problem because we're not dividing by 0. Okay? So then I'm going to write the domain of G to be all x's starting from minus infinity to minus 2. And minus 2 is not included, so I'm going to put an open bracket. And minus 2 and 2. And 2 and infinity. I don't want 2 to be my domain, nor negative 2, so I sort of like excluded them from my domain. Okay? How about the range of G? So range is the set of all images for the x's coming from the domain. The bottom here is the absolute value function, and it's always positive. So you're dividing 1 by a positive number all the time. So we know that it's going to be non-negative. Well, then you should ask this question, can this value be 0? Well, probably not, right? Because you have to divide it by infinity, but infinity is not a real number. So essentially 0 in the range cannot be achieved, but I know that everything is going to be non-negative, so 0 is open. And when you get closer and closer to 4 for x squared, so you're dividing something by a very small number. So the range is going to be 0 and infinity.